Callisto is the fourth most distant of Jupiter's satellites discovered by Galileo. It has a significant size, 4,821 kilometers in diameter, which is 99% of the diameter of Mercury and only slightly smaller than Ganymede and Titan. The satellite was named in the feminine gender. Callisto was the mistress of Zeus, whom, according to legend, he turned into a Medusa and placed in the sky to escape the wrath of his wife Juno, Hera. He held the bear by its tail. That's why it looked so long, like real bears. Callisto is at a considerable distance from Jupiter, 1,882 kilometers, and the length of its orbit is 11,818,960 kilometers. On this huge journey, the satellite spends relatively little time, 16.7 days, in the same time it makes one revolution around its axis. Our Moon, which orbits a path 5 times smaller, takes 11 days longer. These figures once again demonstrate how big Jupiter is and how strong its gravitational influence is. Structure. Although Callisto orbits synchronously with Jupiter, due to its considerable distance from the giant, it is not in orbital resonance with its largest neighbors, Io, Europa, and Ganymede. In addition, its orbit is almost circular, hence it does not approach or move far away during its orbit around the giant, but remains at approximately the same distance. Because of this, Callisto is not subject to tidal forces like its closer neighbors to Jupiter, and its insides do not heat up. The surface of the satellite is very cold, with an average temperature of -103.5 degrees Celsius. Scientists believe that the satellite does not have a hot core, and in the process of its formation, silicate rocks simply slid down, forming a small rocky core inside. Studying the effect of Jupiter's magnetic field on the satellite, scientists concluded that it does not penetrate deep inside, as it is prevented by a solid layer of electrically conductive fluid. This allows us to conclude that on Callisto, as on Europa and Ganymede, there may be an under-ice ocean. The Galileo apparatus during its mission from 1994 to 2003 measured the depth of this ocean. According to its data, it turned out to be about 100 kilometers. But how can a liquid ocean exist on such a cold celestial body? It is quite possible if it includes ammonia. Spectral analysis showed the presence of ammonia on Callisto. This significantly reduces the freezing point. The depth of the ocean in this case can reach 300 kilometers or more. However, the conditions for the emergence of life in such an ocean are much less favorable than on Europa. Poor mixing of water with rocks and low temperatures make the existence of any living organisms on Callisto unlikely. The lithosphere, or upper layer of the satellite, consists of an ice crust 80 to 150 kilometers thick, perhaps even thicker. Surface. Callisto is the darkest of the Galilean satellites, reflecting only 20% of the sun's rays. Spectroscopy has revealed the presence of water ice, carbon dioxide, silicates, and organic compounds with carbon on its surface. The entire surface of the satellite is littered with impact craters. No other planet or satellite in the solar system has as many craters as Callisto. There are no mountains, volcanoes, or tectonic faults, but rather plains covered with craters. On the surface, you can also see chains of impact craters, sometimes merged together. It is assumed that they were formed when the remains of space objects collided with Callisto, destroyed by tidal forces due to their close proximity to Jupiter before colliding with the satellite itself. Some chains may have formed in soft oblique collisions followed by the destruction of the falling bodies. The satellite is very ancient, over 4.5 billion years old, so for every old crater you can see several young ones partially destroying it. There are 2 huge formations on Callisto. The first is Valhalla, a multi-ring structure 1,800 kilometers in diameter, consisting of a central bright region 600 kilometers in size and multiple rings 4,000 kilometers in diameter. It is one of the largest impact structures in the solar system. The other is called Asgard and is slightly smaller, with rings 1,600 kilometers in diameter. In the center is a huge impact crater dough with a diameter of about 50 kilometers, but its center is not in the shape of a bowl as usual, but protrudes in the form of a dome. How did these ring structures originate? There are several hypotheses, one of which suggests that the impact of a very large body caused wave motion of the lithosphere lying on a liquid base, possibly an under-ice ocean. Thus, the concentric rings formed like circles on water after a rock throw. Another peculiarity of Callisto's surface is that despite the many craters, the relief is considerably smooth due to the specific erosion inherent in cold cosmic bodies. The temperature on the surface reaches -108 degrees Celsius in the Sun, which, combined with the absence of an atmosphere, contributes to the unusual erosion. When weak sunlight falls on exposed rock strata and ice, it can cause the ice to slowly evaporate, sublimation, directly into a gas, bypassing the liquid phase and dissolving into space. As the ice vaporizes, the dust and rocks mixed with it gradually slide down the slope. Because there is a lot of ice on the satellite, craters and other irregularities gradually erode. That is why small craters, less than 1 kilometer in diameter, are almost never found. They are quickly smoothed out, shafts turn into hills, and craters turn into small depressions. Atmosphere and sky. The composition of Callisto's atmosphere is not yet precisely known. Like many other small planets and satellites, Callisto's gas envelope is very thin. It is thought to consist mainly of carbon dioxide. At such a low pressure, 1.3 million times Earth's pressure, such an atmosphere would quickly disappear in a matter of days. The persistence of the atmosphere indicates its constant replenishment, probably due to sublimation of frozen carbon dioxide, which is consistent with the hypothesis of crater degradation due to ice sublimation. During one of the Galileo flybys, the ionosphere on Callisto was found to have a high electron density from 7 to 170,000 per cubic centimeter, which cannot be explained by photoionization of atmospheric carbon dioxide alone. There is a suggestion that Callisto's atmosphere is actually composed mainly of molecular oxygen, whose mass fraction is orders of magnitude greater than that of carbon dioxide. However, this assumption requires further confirmation, as there have been no direct observations of oxygen in Callisto's atmosphere yet. Because of its weak atmosphere, the sky on Callisto is very dark. From its surface, we would see a landscape similar to that of the Moon because of the many craters, and Jupiter, whose apparent size is about 2.5 times that of the Moon in the Earth's sky, or 9 times that of the Moon in the Earth's sky. Radiation levels and colonization possibilities. A magnetometer on the Galileo spacecraft has detected a variable magnetic field on Callisto, indicating the presence of a conductive fluid beneath the surface, probably an under-ice ocean. Despite the very weak magnetic field moment, radiation levels on Callisto's surface, due to its considerable distance from Jupiter, are 7 times lower than on Earth, making it safe for humans. This and the lack of volcanic and tectonic activity makes Callisto very attractive to colonize or establish a base for studying the Jupiter system, producing fuel from ice and servicing ships. In 2003, NASA named Callisto as the most promising site for colonization. The JUICE mission, scheduled for 2023, is expected to study Jupiter's largest satellites, including Callisto. These studies, together with other projects, could bring new insights into the evolution of planetary systems and astrobiology. We may be witnessing amazing discoveries and first steps